Let's start section 1.4. Let's talk about solving quadratic equations. We'll solve lots of different equations, lots of different types of equations throughout the course. And one of the most important things we need to do is recognize what type of equation we're looking at so that we know what strategy to use to solve the equation. We already looked at a linear equation like 3x plus 5 equals 10, for example. A linear equation is one where the variable is not raised to any power. Or another way to say that is to say the variable is only raised to the first power, since x to the first is the same as x. In a quadratic equation, like we're going to study now, the variable is raised to the second power. And it may also have a term where x is raised to the first power as well. So in general, a quadratic equation can be written in the form ax squared plus bx plus c is equal to 0. And there are 4 different ways that we're going to learn to solve a quadratic equation. They're listed out for you. The first method is factoring, and we'll get to that in just a moment. There is one other thing that I wanted to say. We just finished talking about complex numbers, and the reason we studied those before the quadratic equations is because some quadratic equations require non-real complex numbers for us to find the solutions. And so we'll see that as we go on through the section. But the point I want to make is we did not need a non-real complex number to solve a linear equation, but we do now to solve some of the quadratic equations. Okay, let's get on to this first method. It's to solve by factoring. And I have a couple examples written out here. And so let's see here. Hopefully some of this is review for you. We'll go pretty quickly through the method of solving by factoring. What we have here is we have the x squared term. We have x to the first, and we have a constant, and then we have the whole thing set equal to 0. And so this on the left is called a trinomial because there are 3 terms. And in order to factor it, we want to find 2 numbers that add up to 8 and that multiply to 8 and add up to -6. So we could write that out. We could say 2 numbers that we don't know. We'll call them m and n. M times n must equal 8, and m plus n must equal -6. And you could go through and make a list of combinations like that. Maybe we should do that one time. So what are 2 numbers that multiply to 8? Well, you could have 1 times 8, or you could have 2 times 4, or you could also have the negatives. -1 times -8 would make +8, and -2 times -4 would make a +8. And so once you have that list, then you can go through it and see which combination adds up to -6. And so it's the -2 and -4. And so we'll use those 2 numbers to write our factors. And so the first factor will be x minus 2, and the next factor will be x minus 4, and all that is equal to 0. And so we can check that this is correct by simply multiplying out x minus 2 times x minus 4 and verifying that really does simplify, or that really does multiply out to x squared minus 6x plus 8. Okay, so once we have it in this factored form, then we can say that if the product of these 2 factors, right, the first factor again is x minus 2, and the next factor is x minus 4, and if the product of those 2 factors is 0, then we know that one of those factors must be equal to 0. So we can just take each factor and set it equal to 0. And when we have x minus 2 equals 0, we solve for x by adding 2 to both sides, and we get the first solution, x equals 2. And then for x minus 4 equals 0, we can add 4 to both sides and get x equals 4. And so 2 solutions, 2 and 4, we can write that in set notation with the braces around it. We could also go back and check that our answer is correct by taking each of these numbers separately, going and checking that x equals 2 is a solution by plugging it in and seeing that the equation is satisfied. And then we could take 4 and we could see that the equation is satisfied for x equals 4 as well. Okay, so let's go ahead and make this problem a little bit harder. The thing that made part A easier is that the coefficient on the x squared is 1. And when the coefficient on x squared is not 1, in this case, in this next equation, the coefficient is 10, then there are a few more steps that we need to do. And so we're going to, first of all, so let's go ahead and start solving this equation. First things first, let's go ahead and set the equation equal to 0. We've got to have the equation equal to 0 so that once we factor, we can set each factor equal to 0. Right? That only works if the equation is set equal to 0. It doesn't work, it's not true, if the equation is equal to 2, for example. Okay, so our method is called factor by grouping. And the first thing that we want to do is just subtract 2 from both sides and get 10x squared plus x minus 2 is equal to 0. And then we're going to proceed in a similar way to the previous example, similar but different. So bear with me here. The steps are a little tricky. This time we need 2 numbers that are going to multiply not to -2, but instead we need to take that -2 and multiply it by this coefficient on x squared, 10. -2 times 10 is -20. So we want 2 numbers that multiply to -20, and then we want those same 2 numbers to add to the coefficient on the middle term, which in this case is a positive 1. Can you see what those numbers are? We could list out all of the factors of -20, but hopefully with a little practice, with a little review, that won't be necessary. And let's see here. If we try 5 and -4, 5 times -4 makes -20, and 5 plus -4 makes positive 1. And so we're ready to use those 2 numbers to do the next step in the factoring. But now we can't write our factors right away like we did in the previous problem. Instead, it will take a couple more steps. So what we're going to do, what we need to do next, is we need to rewrite the middle term, the plus x, as the sum of 2 terms. And those 2 terms are given by the numbers 5 and -4. So we'll have a plus 5x minus 4x, and then a minus 2 is equal to 0. So we can see that the new equation is equivalent to the previous one by simply adding 5x minus 4x back together. And you're looking at this, and the thing that's tricky about this is we've made the equation more complicated here, and so that's not usually what we expect to see, right? We expect as we simplify to make things simpler or less complicated or fewer terms. And we're not doing that in this particular step. Things will get simpler here in a minute, or simplified here in a minute, but for now, things have gotten more complicated. Okay, so what we can do now is we can go ahead and do some factoring. And in particular, we want to look at the first two terms and the next two terms. And we just want to factor the greatest common factor out of those first two terms. So can you see what it is? 5 and 10 would have a common factor of 5, and the x squared and the x would have a common factor of x. Take 5x out of the first two terms, and you will have 2x plus 1 left over. And then out of the next two terms, factor a negative 2. And what do you have left over? 2x plus 1. This is a really important point in the problem. Here at this step now, you see that what was left over in the first set of parentheses is 2x plus 1, and in the next set of parentheses, it's exactly the same thing. If factor by grouping is working, then the two sets of parentheses will contain the same expression. If you have a different expression in the two sets of parentheses, then you know there's a mistake. Okay, so now we can factor again. So we're going to look at these two long terms here, and we say, well, they have something in common, don't they? They have a factor of 2x plus 1 in common. And so we can take that out. And what's left over? In the first term, 5x is left over. And in the second term, minus 2 is left over. And so here we have our factors. So it took a few steps, but now we've got the thing factored. So this is a good feeling. We can go ahead and take each factor and set it equal to 0, and we're almost finished with the problem. So if you subtract 1 from both sides of the first equation, you get 2x equals negative 1. And when you divide by 2, you get the first solution, x equals negative 1/2. And for the second equation, we would add 2 to both sides and get 5x equals 2. And then divide by 5 on both sides, and x is equal to 2/5. And so those are the two solutions, and we might write that in set notation with the braces around it. Okay, that's a tricky problem, and it's one that most students need some extra practice with. So let's go ahead and try to work one more of these. We'll call this example C. This will be the last example where we solve by factoring. And so we'll have 3x squared minus 8 is equal to negative 10x. You might pause, if you're feeling good, you might pause the video and try to work through the steps on your own, or you might try to rewatch the previous example and then work through the steps on this problem on your own. Remember, the first thing that we need to do is we just need to set the equation equal to 0. So we're going to add 10x to both sides. And we're going to order the terms from the highest power on the variable, 3x squared. And now 10x to the first. And now the constant last. And we have that equal to 0. we want two numbers that are going to multiply to the product of 3 and -8. 3 times -8 is -24. And the sum of those same two numbers should be, the coefficient on the middle term should be a +10. And so if we think real hard about that, let's see here. 6 and 4 sound tempting, but the signs won't be right. What we're going to need is 12 and -2. They multiply to -24 and they add to 10. So we're going to use those two coefficients to rewrite the middle term. We'll get 3x squared plus 12x minus 2x minus 8 is equal to 0. Would it matter if you wrote minus 2x first and then 12x after that? No, it wouldn't matter. The next step or two would look a little different, but then you would wind up with the exact same factors at the end. You might try that if you want. Okay, we're going to factor out of the first two terms a common factor of 3x. And then you have x plus 4 left over. And then out of the next two terms, we have a -2. And there's an x plus 4 left over. Notice we have the exact same expression in both sets of parentheses. So that's a good thing. And here, let me go ahead and put some bracket. Just group those last two terms together to remind you that we factored out of those last two terms a -2. And then we can go ahead and factor from these two big terms. Let's see here. There's a term. There's a term. They have a common factor of x plus 4. And in the first term, there's a 3x left over, and in the next term, there's a -2 left over. So there are the factors, and we can finish this off. We can set each factor equal to 0, and we'll have our solutions. We'll have x equals -4, and we'll have let's see, add 2 to both sides and divide by 3 on both sides, and we get x equals 2/3. And we'll write that in set notation. Okay, we'll pick up with the quadratic formula in the next example, in the next video.